this computer. It's now recording. I'll put 1 in it. Now, so executor service. So executor service is a way for us to manage threads. Okay. What's actually happening in the background is that threads are basically created as you need them. All right. And so you can think of when I do this guy down here. Okay. So executor service. So this is something that's going to manage our threads. It's an object that will manage our threads. Now, this guy here, so service, executors, new single thread executor. That's what creates a thread. Okay, so that creates a thread. Now, you don't have direct access to the thread, but all you want to do with the thread is add tasks to it. That's all you want to do. Morning, Rod. I am. Okay, so executor service, this is going to be a service that looks after threads. Now, a service can look after many threads or one thread. Okay. Now here, so service is equal to executors, new single thread executor. Okay. That basically creates one single thread in the background. Okay. So that will create one thread. This one here, this creates another thread. So we have two executor service objects. These are going to be objects that are going to manage threads. Okay, so this one, so I'll bring up my pen. So this one is going to be that thread. This one is going to be that thread. Okay, now you don't have direct access. You don't need direct access to thread, so you don't have to call the methods of the thread because this executor service does it all for you. Okay, now how will you get your thread to start? You have a method called execute. Okay, now but before I do that, I want to explain. So this guy here, new single thread execute. All right, so what is this guy? So I'm going to put in a comment for this guy. Okay, so new single thread executor, which is that guy. Clear all this shit. Slide down here. Is the simplest executor service you can create. Okay, this will result in a single thread. So all tasks in this thread will run concurrently. Now, you can add as many tasks as you want to this thread. Okay, so you can add as many tasks as you want to this thread. Okay, so a task is an object that implements a runnable interface a simple runnable interface, which is, so it returns nothing, takes no variables. Okay. So, so execute is the method here. Okay. To get our thread to start, we have to use execute. Okay. So execute takes a object that implements a runnable interface, can be a lambda, can be a object of a class that implements, can be an object of a class that implements runnable, or can be a full nested inner class. Now, more often than not, it's going to be a lambda. Okay, more often than not. So that guy there, this implements the runnable interface. It implements the run method. So it takes no arguments and returns nothing. Okay. Now, so this creates only one thread, which means everything will be in order. Now, so execute is considered a, and this is the name of the method, fire and forget method. As once it is submitted, the results are not directly available to the calling thread. So server.execute, it's not returning anything. So it can't be assigned to anything. All right? It's not taking any variables. All right? So that's why it's called a fire and forget method. It does its work and you're finished with it. All right? Now, remember the rules for a lambda? A lambda can only access a local variable if it's final. It can access all variables of a class. All right? So if it's a local variable, it has to be final. So if I had a variable inside here, it could access that variable inside here as long as that is final or effectively final. If I had a variable outside of the methods, so that would be a variable of the class, they don't have to be final. Static variables can also be accessed inside here. So local variables are the only ones in a lambda that have a restriction on them. Restriction is they have to be final or effectively final. So if you wanted, if you had some sort of calculation going on here and you wanted to be able to access it outside of the lambda, you'd either have to have some variable of the class inside here and assign it to it, or you're going to have a static variable inside here and you assign to it. Okay. Now, so we go here. So how do we start our thread? We start our thread by going, the keyword is execute. Okay. So you can have as many, so this execute, so this basically creates our thread, and it's going to be managed by this executor service called service. Okay. This guy here creates a second thread, and it's going to be managed by this executor service, service 2. Now, so service has got, how many tasks has it got on it? It has got this task, it has got this task, and it's got this task. So it's got 3 tasks on the thread. Do we see that? Yeah, that's what a thread is. You load up tasks on a thread. Okay. Now, these are all threads that are running one after another. So there is no concurrency issues here. all right? Because this is going to run first, this is going to run second, then we have service 2 kicking in here, but that's going to be service 2. That's going to be the first task called for that one. But they're all going to run in order. That's going to run first, that's going to run second, that's going to run third, that's going to run fourth. Yes? Do we see that? Any questions on that?
So service 1 waits until service 2 is finished until it does its third task.
Here, yes, it does. Okay. Now, because this is a new single thread executor. All right. So basically, it does its thing, goes on to the next one.
How is it aware of service 2? How does it know to wait? I mean, service 1, so it can do its third task.
So where?
Oh, what
Here.
I'm saying now, so you see how you have service and service 2?
Yeah.
Yeah. So you have a service after a service 2?
Yeah.
I'm saying, does that service wait until service 2 is finished executing?
No, 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 it doesn't. So that one there does it. That one there does it. Then the first task in service 2 executes.
Yeah. And that one's doing it at the same time.
Yeah. Yeah. So but it's done after that part.
Yes.
See all this executor, this thing here manages it. Okay. Now, these types of threads, there isn't much performance gains in them because everything is still running after one after another. Okay. Things aren't running together at the same time. Do you well understand that? Okay. With these type of threads, there isn't an awful lot of performance gain. In actual fact, there probably isn't any performance gain. All you're doing is you're creating a thread. And the thread is going to consist of many tasks. All right. So that's service. And this is service 2. Now, I've already shown you yesterday, so I'll just show you it again. The thing about threads is threads will keep on running. All right, keep on running. For instance, right. If you go Control-Alt-L in your task manager, you clicked on services, they're all threads. They're all threads that run in the background in Windows. Now, I don't know if you have access to one of those machines. They're all threads. Okay? So services run in Windows, they're threads. Simple as that. All right? So a thread can run continuously in the background. All right? Which has, so if you have something that's, you need to be constantly monitoring something in your app, you have to have it as a thread, or you can have it as a thread, right? So a thread allows you to constantly monitor things. Now, if, so this guy, so this causes, that's the task, it's one task. That's something that implements the runnable interface, that's a runnable lambda. Now, dog is a class that implements runnable, public void run. So I can put in there an object that implements the runnable interface, which is a dog. I have another one down here, server.execute. So this is stream.iterate, starts at 0, goes up by 1, limited to 10 for each. It's going to take in the number and it's going to print off I is 1.
Are we saying that you've got 2 threads there, service and service 2?
Yeah, well, they're services that manage a thread, a single thread.
There's 2 threads there, though, isn't
There is, yeah.
And there's service 2.
Yeah, well, it's not so much that they're threads, they're an executor service that manages the thread.
Okay, well, yeah, okay. Yeah. Are we saying that service, the first one, service, will complete before service 2 begins?
No,
They run
won't.
together, but then,
Well, they actually run in order, right? They run exactly in the order you see here.
okay.
So they are, yeah, so it's going to be going on 1, 2, 3, 4. Now 3 is a different thread, but its first task is executed after the first 2 tasks of the first thread.
task 4 on the first one will have to wait until the service 2 bit is done. Is it?
Yeah. Well, so it goes. So here's our service thread. Now, service thread is made up of task 1, task 2, and task 4. Now, service 2 is made up of just task 3. Now, the executor service, what it does is, so that runs first, that runs second, that runs third. Okay, it's not that they're running together at the same time. Well, the services are running together at the same time, but their tasks aren't. That task completes. That task completes. Then that task completes. Then that task completes. Okay? Now, so yeah, that's fine when you're just doing 3 or 4 tasks. That's grand. Okay, you can let your service execute, so that's fine. Now there is issues when you start coming to more threads, which we'll come to in a minute or two. Now, if you want to do your business, do whatever you want to do, and then you want to shut down your service, okay? Because threads, if it's doing a serious amount of computation in threads, it's going to slow down your app, okay? If you just need a service to do something, then you should shut it down, all right? Just wanted to get a value from the database. You don't want to keep the connection up to the database because security risk. You just shut down the service, you no longer have access to the database, okay? So, finally, now, I created service and service 2 outside of the try-catch block. The reason I created outside the try-catch block because I want to be able to shut it down in the finally. So finally runs. So the command is shutdown. So is shutdown returns a Boolean. Okay? Is shutdown returns a Boolean. If it is shut down, it's going to return true. If it's not shut down, it's going to return false. So what we're saying there is the service not shut down? So if the service is not shut down, so put in here, is shut down, returns true if the thread is closed, false if not closed. So this is saying if this service is not shut down, what do? We shut both of them down. This closes both threads. This closes, or this shuts down both services, which closes both threads. Okay. Now, previously, if we wanted to do that, you'd have thread.close. And a lot of the time, by the way, that won't work. Here, it'll always shut down the thread.
If service is shut down, do you have to do that for service 2 as well?
Well, ideally, yes, but I'm just checking for one of them.
Okay.
Okay. So if service is not shut down, we go service.shutdown, service2.shutdown, service.shutdown. Okay. Now, of course, here, you don't really need 2 services. One would do, because you're just doing 4 tests. All right. So you don't need a separate thread. One thread would be more than sufficient there. Because all the threads are about, it's about logical units of work. So you have one thread looking after your database. You have one thread looking after accessing your files. You have one thread looking after your GUIs. You have one thread looking after your security. Okay? So, and you add tasks to it as you're going along. You only shut down the thread when you're sure there's no need to use the thread again. Okay? So, some threads are going to be open the whole time you have your application open. All right? And as I've said, anything that's going to be outside the thread is in the system thread. So everything you do in Java is on the system thread. All right. So if you don't have something on a thread yourself, it's on Java's own, or it's on the system thread. I think that's what it's called. Okay. So everything is done on threads, whether they like it or not. Okay. Now, so why do we need shutdown down? So if I said, if we don't have a shutdown, the service will keep running indefinitely. Okay, which you may want if there is some thread that contains tasks that need to be constantly operating in the background of your app. Something to do with security. Okay, you can imagine you want to make your thread that's managing your security there constantly monitoring in the background. Okay, if you have any sort of graphics that are interactive, you need a thread in that case because it's constantly going to have to be reacting, for instance, any sort of game. All right. Now, so good morning, Alex. So I'm going to put in here Executor service does not implement auto-closable. So you cannot use try with resources with the Executor service. Huh?
That was with files.
What? The auto-closable? No, we did it with exceptions. Okay, we will be doing it with files because all the file classes do implement auto-closable. And so do JDBC, which we're going to be using to connect to the database, as far as I know. Okay. Now, however, does not, so you cannot use try with resources with the Executor service. Now, we are going to create a, so we're outside of EX2, EX1, and I'm going to create a public static Executor service. I'm going to call this stat service is equal to null. Now that is the wrong spelling. Now what I've done there is this is going to be a object that's going to manage threads, and it can be accessed anywhere and everywhere. Okay, so we're going to be accessing this in different classes, and we're going to be adding tasks to it. Okay, so let me just see. So I'm going to go try. Oops, sorry, wrong one. So this is static void ex2. And what is this? This is a, so this is a static Executor service. Now, so inside this try block, I am going to create a thread. So I'm going to say stat service is equal to executors dot new single thread executor. Okay, now that creates a let me just see, give me a second. Okay, that will work. All right, so I've created it outside of there, so just give me a minute. Put in a finally here. I'll explain what I'm doing in a minute. Right, so now it's not that guy that you have to put in a try catch block. What you have to put in a try catch block is the execute part. Okay, so that service start execute. So here so execute is adding a task to this thread. Okay, so execute is adding a task to this thread. So we're going to do, so we're implementing the runnable interface. So we're going to put in a lambda here.
So what does that need to be?
Basically because, all right. Yeah, just give me a minute now. Just a minute, I'll put in something in here. I'm going to say now, believe it or not, the reason you really have to put in a try catch block is because in the finally, all right, finally always runs. The real reason you put it in a try catch block is so that the finally block is going to be able to close it. That's it. That's the real reason you put it. Okay, you don't absolutely positively have to do that. All right, but the problem with that is you're not always assured that that's going to execute. Something might go wrong. Okay, but the finally, you're always assured with the finally. Now, what I put in the finally is I'm going to close the service. So you're always going to be sure, no matter what happens, the finally will shut it. Okay, so exactly. Okay, now when we come to other types of executor service, they have to put in a try finally. They have to put in a try block. Okay, because they throw exception. This one doesn't absolutely positively have to put in a try finally block, but the reason it's put in a try finally block is so that the finally can close any service. That's the real reason. Okay, so now I create it up here, and inside here I execute it. Okay, now, and if I go if go here, stat service is shut down. If it's not shut down, what do we do? I go stat service dot shutdown. Okay, and I just always checking it. No harm to always checking it. Stat service shutdown. Question mark after it. And I go stat service dot shutdown. I'm going to run that guy. Okay, so okay. Oh, it's not shutdown, sorry, is shutdown. Right. Now, so the static void ex2. I'm going to go to main. Right, so shutter, right? Fine. Now, so if we saw in the cat class, okay, so we have a cat. Now, in the cat class here, I am going to create a constructor. And what am I going to do with the constructor? I am going to add a task to the stat service thread. Okay, so I go in here, cat constructor called, and then I'm going to go examples dot stat service dot execute, and I'm just going to put in some sort of command inside here, and we're going to say this is print out cat executor. Now, so whenever we create a cat, we're also adding a task to this thread. Okay, so if I go here, if I create cat, my cat is equal to new cat. See it? See our separate task, right? That is one task. The cat class, inside the cat class, there is another task added. Okay, they're all on the same thread. All right, so what happens there is this task is going to run first. The next task that's going to run on this thread is going to be inside the cat constructor. Okay, we could, so this will only run after that guy. All right, so that runs first, then we create a cat, and that then adds a second task to our thread. Okay, so that's what a thread is. You're adding tasks to it, and they're all running in that thread. All right, so this guy here, this is our first task on our thread. Okay, this is our first task on our thread. Cat. The cat constructor adds another task to the stat service thread. Now I'll call them thread, even though they're not thread. It's a service for managing a thread. Okay.
No, you say they're static.
Mm-hmm.
Stat service. Why is it static? Why does that be static?
Well, the reason it's static is because we're inside a static method and you can't access non-static. Okay. If it wasn't a static method, then it could access it. Okay. So stat service, and when it's a static, you don't need to create an instance of this class. So we can just go examples.stat service. Okay, so this is our static thread that is contained in examples. And here we are adding the second task to the thread. Okay, so it's a static method. It can be accessed. It's a static thread. It can be accessed anywhere. Okay, now if you have, let's say, a non-static thread. So if I say executor service, I'll just call this service. Jesus Christ, it's getting awful dark. Okay. Executor, what's it doing, Roland? Is it snowing or what?
Sorry?
Is it snowing or what is it doing?
Oh, yes.
Oh, yeah, I thought you're outside. So, okay. Executor service, all service is equal to null. Right? So I want to access that. So you can only access this inside EX2 if you create an instance of the class. So you have to go examples, EX, my EX is equal to new examples. And then I go my EX dot O service is equal to executors executors dot u single thread executor. Oops, sorry. Okay, in actual fact, I can change that. I can put that up here. And I'll make it public. So public executor service, all service is equal to my executor new single thread executor. So again, you just go the same way. My ex o service dot execute. We can add something to it. So this is o service thread service. And we can add anything to that thread as well. Okay, so we can add anything to that thread. So that's one thing added to that thread. And I can be inside here, my ex.oservice.execute. And this is going to be quite simply see, now does it work? Okay, it's not a runnable object. Okay, so I'm going to go here. I'm going to go here. This is second task in this thread. Okay, so this is a non-static service. This is a static service. Okay, they both operate the same way. Is everyone with me so far? Yes. So that is the first task. This is first task on this thread. This is the second task in this thread. Okay. Now, so we run all of that. Now, look at this lad here. Why is that lad still going there? That means the thread is still running. Which thread is still running? That one. Okay, because I haven't shut it down here. If you don't shut it down, your thread will keep running. Which isn't always necessarily a bad thing. But in this case, we've done it. We don't want to do any more. So what do? We just go inside here. And I need to shut it down. And then I just go simply here, my ex.oservice.shutdown. Now I run it. We've got everything there. Okay. Now, so if you have a static executor service, you can access it anywhere. You can add tasks to it anywhere. You also can shut it down anywhere. All right. What do I mean by that? All right. I need to be careful how I do this. See. I just want to try, just give me a second here to make sure that this is working right here before I do it. Okay, so if I go down the screen here, and this finally will shut it down. Yeah? Okay, so I am going to come in here and I'm going to create, so stat service is an existing service that can manage a thread. So what do? We create a new thread on it. So stat service, that's going to be here. So I go stat service dot is equal to executors dot new single thread executor. Okay, so that creates a new thread. Okay, so this shuts down. So stat service manages a thread that shuts down the thread that this manages. Okay, this creates a new single thread. That means a thread that runs one after another, and that's what's going to manage it. Okay, right. So I'm going to do a try.
No, if you had to shut down, you couldn't use the same reference.
No, no. So if I tried to do, right, so just take that out there for now. If I went, isn't that sense? Just give me a second. Right, so I'm going to have a try, and I'm going to have a finally. Okay, so if I go here, stat service dot execute, and I try, and I'll say next command to be next task on this. Right. So try and run that. So what you get there is rejected execution exception. Okay, so this will generate rejected. I'll just copy it. Rejected execution exception as the thread at the service has already been shut down and the thread it was managing has been closed. So that shutdown also closes the thread. So it shuts down the service, which closes the thread. That's what it does. Okay, so this will generate a rejected execution exception. Now, if I have a catch block should catch that. Let's see. So that should catch it. Let me just see. Yes, it does. Okay. So stat service execute. So that generates a rejected execution exception, as this service already been shut down and the thread it was managing has been closed. So what we're going to do is we are going to create another thread. Okay, so I'm going to take this one. So what this does is this creates a new thread that stat service will manage. Okay. Now, if I go stat service dot execute, I'm going to try and do it outside of a loop or outside of a try block this time. I'm going to say first task on new thread. Cancel. Okay, so everything seems a-okay. Yeah. Now, if I create, if I do another one, stat service execute, I'm going to say very simply, God bless you. Second task on new thread. God bless you. So that's our second task. Now, ideally, you should really have these in a try catch block. Okay? Because let's say if I go new cat. Okay? So if I go cat, my cat, stick to new cat. I think this is the one that generates the exception. Okay, it doesn't generate an exception. I think why it doesn't. It should. I don't know why it isn't. Anyway, now, so that creates, that's the first task. That's going to be the second task. This is going to be the third task. Is everyone with me so far? Yeah? Right. Now, I think you can go stat service dot shut down. Okay, that will shut it down. But what I'm saying is, if something happens, because the execution can be complicated enough, things that's happening. If anything happens in any of those services, okay, then your thread will never be shut down. That's why it's in a try finally. That's really the only reason it's in a try finally. Is everyone with me there? Does everyone understand that? Okay, now. Right. Now, what they actually recommend when you want to shut down a service is that you shouldn't use stat service.shutdown directly. Okay? What you should do is you should have a static method that shuts it down for you. Okay? Now, I don't think it's working here for me, but I'll try it anyway. So we go shut down thread. Okay? That's what I call it. Then I go why is it giving me a why is that giving me an error? Why is that not giving me an error? Hold on, try that again. I don't know why that's giving me an error.
Oh, you're still in the yes.
Ah, yeah, fuck it. Okay. All right. So, ideally, what you're supposed to do is you're supposed to have another separate method that shuts down these executor services. So, yeah, a static executor is what you use if you want different classes to be added to a thread. Okay, so cats can add to this thread. Dogs can add to this thread. Ostriches can add to this thread. Okay, now it's not recommended that any of these classes should shut down this service. Okay, it should be shut down in one place and one place only. Does everyone understand that? Yeah. So I could have, let me just see what happened to the dog here. So I'll do the same with dog. Dog implements runnable. So I should be also able to do this. I should be able to see stat service dot execute new dog. Okay, because the dog class implements the runnable. Okay. Okay, so this is the first task. This is the second task. The cat class, in the cat class constructor, a third task is added to the thread, and dog implements runnable. So this can be put in an execute as an argument. Okay, so here we have, these are going to be, this is, so this is the fourth task. Okay, so this thread has got 4 tasks on it. It has 2 tasks inside this static method. It has 1 task that happens inside the constructor. This guy here is another task because the dog class itself implements runnable. So when you create a dog, you create a task. Is that okay?
Our dog then just disappears.
Yes. Okay, because execute is, as I said before, a fire and forget method. Okay, dog disappears there, but there's nothing stopping you from doing this. You're using an existing dog. Okay, so the dog still exists after it. See that? And by the way, there's nothing stopping you from inside the runnable method from changing the aspects of the dog. Remember that? So if the dog had an age and a weight, the run method inside the dog class could change the aspects of the dog. So that is one way of keeping values after it. Yes, Kevin?
Cat here doesn't implement the runnable.
No.
Doesn't have to.
No, because cat adds to the service inside the constructor. See that? It's adding a task to stat service. Okay, so cat doesn't implement runnable. Okay, it's in the cat class constructor, a third task is added to the thread. Whereas here, dog implements runnable, so this can be put in an execute as an argument. So spot is a task. Simple as that. Okay. That inside the constructor, there's a task. That's a task. That's a task. So you're adding tasks to a thread. All right. Now, this guy here. Now it doesn't work here, so I'll just kind of see, does it work? So if I go, so if I call that method, I just go shut down thread. Let's see, does that work? Yeah. Okay. So what we're doing there is, instead of using stat service.shutdown, we're using a static method. Okay, it does the same thing, but there's only one way we have. So what you normally do is you normally have a static method to shut down your thread. Okay.
Is there any way of encapsulating that?
Encapsulating what?
The shutdown, because anyone can shut down the thread. They can shut down anywhere in the thread.
Well, you make that private. Then it can only be shut down inside the example class. Do you get me?
Yes.
So by making it private, it's only this class that can shut it down. Do you understand me? So
If that service is equal to null,
well, that's another way of doing it.
this is just another way to-
Yeah. So I suppose I'll keep it that way. So uh, so that should shut it down. Yeah, that shuts it down. Okay. So I'll put in here. You should only have one way and one way only to shut down the threads, shut down the service. Okay. You shouldn't be shutting it down in the cat class. You shouldn't be shutting it down in the dog class. It's just a general thing. All right. So the only way you can shut it down is inside the example class by using this static method. Okay. Now, that's not a hard and fast rule. That's probably true in 70% of cases you should do that. There is going to be 30% of cases where you might want to shut it down somewhere else. See, because the danger is, if you shut down the thread anywhere, for instance, let's say I shut down the thread inside the cat class. All right. So if I go here to the cat class and I go stat service dot examples dot stat service dot shutdown. Right? So when you create a cat, it shuts down the service. Okay? If you do that, I can't add another service to it. Okay? So you should only be able to shut down the service at the end. All right? Now there is various, the rest of the actual, this lesson is all about shutting down the thread in the right place. All right? So the general rule of thumb with programming, don't rely on people's common sense to do anything. All right? So don't rely on common sense that, all right, we want to shut down the thread at the end. Because inevitably, if you're dealing with classes, calling classes is going to get very complicated. You're not going to be too sure when to finish it. By this way here, this is the only way to shut it down. You only use this method. That's enforcing a rule. That means you can only shut down a thread inside this class. Why? Because this method is static, private, and void. All right, so if I go to here to the cat, so if I left this command in, you would be not able to add any more tasks to this thread, and you would get this thing, rejected execution exception. As the thread would already have been closed. So you should only have one way to shut down a service. I'm not going to italicize it because there may be situations, it's going to be confusing for yourself. If you have a cache that's shutting it down and then it just gets too confusing. So you shut down your thread when all your tasks are completed. All right? Now, so that is execute. Okay, now execute itself returns nothing and it takes a runnable. Yes? Right. Now, there is other commands we can use instead of execute. So execute will start, what execute does, it adds a task to our thread. Yes? It adds a task to our thread and returns nothing. All right? Now, there is another command. Check something here a minute, give me a second. So the static void ex3. Okay, so this command is submit. So I'm going to create an executor service again. So this is, I'm not going to bother with the static one now. Executor service is equal to new single thread executor. Okay. Now, so what to submit to? Submit is like execute in that it adds tasks to a thread. But unlike thread, it returns something so it returns something.
Just there, no, you said like execute, I suppose, instead of thread.
Oh yeah, execute, thanks, Kieran. It returns something called a future object, okay, instead of void. Now, a future object can hold information about whether a task is completed or not. Okay, so that's what it's for, because with execute, there is going to be times you're not too sure if a task is completed or not. All right, so with execute, particularly when you're using other types of threads, if you use execute with other types of threads, they're just going to start executing even if the previous thread isn't finished. Now, it's not a problem with the new single thread executor. It's when you come to what are called thread pools. They are the threads that operate alongside each other. If you use execute with those, you could have one thread starting, or you could have 3 threads, and you could have our 3rd thread starting before our 1st thread even starts. All right? So what a future object enables to do, one thread won't execute until another thread is finished. Right? So the future object holds information about whether a task is completed or not. That's what it is. Okay, so submit returns a future object, and that object contains information about whether our task has completed or not. It can also be used for what is called scheduling, which we haven't done at all yet, but it's something that's very useful. Scheduling is, we want something to happen in the future at set intervals. Okay, we have a little loop, or we have a little stream here, for instance. It's going to create a dog every 5 seconds over a period of 20 seconds. Or it won't start for another hour. Or it won't start until a particular point in every day. Or it won't start until 5 minutes after the user logs on. Okay, so scheduling allows tasks to be performed after a set period of time. Okay, or it can be dynamic time. If your mouse, for instance, I know an example. Have any of you got a screensaver there on your machine?
Yeah.
Yeah, that's a thread. How that operates is, if there's no action in 5 minutes, screensaver turns on. So that's constantly operating in the background. That is a thread, and it's a scheduled thread. Okay, so scheduling. So these guys here, submit allows you to use what are called scheduled threads. So you can imagine, do one task. After 10 seconds, do the second task. After another 10 seconds, do the third task. What it does enable you to do, you can have a pool of threads. And let's say you have 50 threads in it. Your second thread won't start until 5 seconds into the first thread, and so on and so forth. All right? It can complete all of the tasks, all of the 50 tasks, and it can also get information from the previous threads. All right? So that's what a future object is. Now, a future object looks like this. So the type is future, and it has a generic. Okay? So it can, a generic means it has to be a, how can I say it? It has to be an object. Okay? Now, more often than not, it's going to be a question mark. All right? So this is one generic that is going to be more often than not question mark. Question mark means it can be any object. Do we understand that? Okay? Because we don't care about, usually we don't care that this future object pertains to an integer. We're just finding information such as, is it done? Is it finished? Has it run? Is it cancelled? Is it closed? They are all methods of that guy. Okay. What the question mark means, that can be, so a future object, that means it's a future object of type integer. All right. Now that would mean, it would be, yeah. So it's the same thing, really. Okay. Now there is, yeah. Sorry. If you don't have that,
Yeah.
yeah. So it's just an object. Whereas if you put that in, it's going to say an object reference to an integer. It's an object reference to an integer object. Maybe, I think, Jason. Maybe that's it. Okay. But anyway. Now, so we will. Now, a future object can hold information about whether a task is completed or not. That's its primary function. Okay. Now, can be also used with scheduling. Now, there is a special type of thread that's called a schedule pool, I think, new schedule pool, which we'll be using with scheduling. Okay. Tasks that will happen at some point in the future at regular intervals. Example of that, i.e. your screensaver will launch after 5 minutes of inactivity. Or your phone switches off after 1 minute. The screen goes blank. It should go blank in 30 seconds. Come on, go blank. Go blank. Okay, see me doesn't go blank when you have it up in the air. That's all threads. Okay, that operates on threads. Your screens will launch after 5 minutes of inactivity. Check all connections on laptop every 5 minutes. Okay, or your automatic updates run at 12 o'clock every day, or whatever. Anything that happens at regular intervals on any electronic device is a thread.
They have to be timed intervals, or can it be?
They can be timed intervals.
Can they be triggered?
A particular time that they can be, right? So they can be, let's say, 10 seconds apart, 10 hours apart, 10 minutes apart.
But I mean, does it have to be? Do they have to be timed intervals, or can it be conditions? Can it be if this variable holds its value, then?
Yeah, of course it can. Yeah. Okay. So you can do one task and something else. So they can be combined with streams. So yes. Okay. So now, so you should use submit whenever possible over execute. Okay. So this is the one you should use. Now it's harder to use than execute. So we showed you execute to start off with because it's easier. But the real one you should be using is submit. Because execute doesn't allow you to check if something has happened or not. Submit does allow you to check. Okay? So we're going to show you a very simple version of it. So I'm going to put everything inside a try catch block because I want to shut it down. Okay? So I'm going to say future. Now I'm going to say question mark my submit. Future. Right. Now, so submit returns an object. Okay. So this is the object that's going to be returned. 1 minute. Finally. Now, so no, it's an actual class. Okay. No, it's an actual class. I think. Let me just double check that here. So I will say, is future a class or an interface? I think in Java. It's an interface. Doesn't matter anyway, because all you care about is the methods. So it is an interface, okay? And it looks like this guy. Okay, so it's an interface. Now all you care about this is the methods. So we are going to create, so if we go service dot submit. Now, did I say this? Which one is that? Now there's a couple of different types of submit. Now there's a submit that takes something called a callable. We're not going to do that quite yet. There's a submit that takes a runnable. There's a submit that takes a runnable and a result. The one we're concerned about here is the submit that takes a runnable. Okay, so it's something that implements the runnable interface. Okay, so we're going to put in a task in here. We're going to say a very simple one. And we're going to say running submit. Now, I'm going to assign this to a future object. So if I go my submit is equal to service.submit system.println running submit. Now, that returns a future object. Okay. Now, that gives us information about whether this task is run or not. All right. Now, some of the methods of it are as follows. First one is done. What this does, so returns a Boolean true if task completed, false if not. Now, this is a simple task and it's not a multi-threaded application. It's a single thread. So this is going to print off true. So if I go my submit dot is done. Oops, so it's ex3. Nice. All right, so now I'm running into the issue. I need to put in here if service right. Now, also, so try my submit is done. That should be. Okay, so running submit. So submit is done. False. Okay. Right. So I'll just try something here a minute. I have to figure out why ex3. True. Okay, my submit is done. So now I know why it's happening. Hold on. Give me a minute here. Dog.
Is it just that it hadn't finished by the time the
Yeah.
system played, but
That's exactly it. So now, right now, so here's the thing. Right. So it's not going to count as being done until let's explain it this way. So this is the future object that's going to be returned from this guy. All right. Now, this won't count as being done until this one starts. Okay. So if you don't have a second one in it, so if I take that one out, It's going to read false. Okay? So it's not going to count that one as being done until the next one actually starts. It's weird. That's the way it is. Okay? If you just have one task in it, that task is not going to be finished until the second one is actually started. Does that make sense?
If you only have one task,
Then, right, so I'll do a couple of other commands first and then I'll come back to this, okay? So, returns the boolean true if task completed. So, returns true if the task is completed. Completion may be due to normal termination, an exception, or cancellation. All right, so you can cancel these guys. Okay. Now, I think what's happening there is that this is not going to be marked as complete until it sees that it can start another task. All right. As soon as it's ready to start another task, that's when that's marked as done. If there is no other task, it can't say for certain whether it's done or not. I'd imagine that's what's happening there. Do you understand that? I think.
It's not to do with printout.
No. Okay. So is done. So I'll actually returns true. So I'm going to copy this comment. Returns true if this task is completed, may be due to normal termination. Returns true if this task is completed. Completion may be due to normal termination, an exception, or cancellation. In all these cases, the method will return true. Okay. If it's not finished, it's going to return false. There. It is finished that task, so it's going to be true. Yes? Now, by the way, it's only about that task. It's got nothing to do with that task. Do we understand that? That this my submit is all to do with that guy. It's got nothing to do with that guy. Yeah, that is right, I think. Let me just check that a second. We will go new dog. Give me a minute here now to check something here. No, that's not going to work. Right. Yeah, that's not going to work because that's not a service. Oh, fuck it. Give me a minute here now. Let's see what I've done wrong. Now, I'll just try putting a third service in here. Runnable. Service.submit. Put in a new runnable. And this is our task and submit. Yeah, so future. Okay, now just give me 1 second to check this. I'm just checking out something here. Submit.get. Null object. Shitski. Take a break because I've done something wrong here. Okay. So give yourself a couple of minutes and then you can go to lunch. Okay. So we'll come back to us. Stars across my heart.